Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, you can go to smarturl.it/help-ISU-actuary. Here's the problem for today. For exam P on probability, losses X under an insurance policy are exponentially distributed with mean 10. For each loss, the claim payment Y is equal to the amount of the loss in excess of a deductible D greater than 0. Calculate the variance of Y. And there are 5 answer choices. For a moment, I didn't have answer choice C there. My apologies. But these are the 5 answer choices that we have here. So we have this, that Y is by definition equal to 0 when X is less than D, and X minus D for X greater than or equal to D. And the first moment, the mean of Y is easily found using the Darth-Vader rule. It's equal to the integral from D to plus infinity of the survivor function of X dx. That's the integral from D to plus infinity of e to the minus x over 10 dx. So it's 10 times the integral from D to plus infinity of 1/10 e to the minus x over 10 dx. This function under the integral now is the probability density function of the exponential distribution with mean 10 that we're working with. The integral of it from D to plus infinity is just the value of the survival function at D, and that's equal to e to the minus d over 10. So the answer is 10 e to the minus d over 10. We also have the second moment of Y equal to the integral from D to plus infinity of X minus D squared times the density 1/10 e to the minus x over 10 dx. There is no nice Darth-Vader rule for second moment, so we just do integration by parts here. Take X minus D squared to be U and V to be e to the minus e to the minus x over 10, so that dv is what we see under the integral. What we have under the integral is u dv. By integration by parts, this is equal to u times v evaluated from d to plus infinity, which in this case is equal to 0 at both ends, so 0 minus 0, 0. And then we have minus minus, so plus v du. Well, v has a minus that cancels with the other minus, so it's minus the integral of v du, which becomes the integral from d to plus infinity of 2 times x minus d e to the minus x over 10 dx. And this equals twice the mean of y, and we just calculated that mean as e of y equal to 10 e to the minus x over 10. So this is equal to the integral from d to plus infinity of 20 times e to the minus x over 10 dx. Which is the same as 200 times the integral from d to plus infinity of 1/10 e to the minus x over 10 dx. And again, this is the integral of the density, so it must be equal to the survival function at d. So this is 200 s sub x of d. So it's 200 e to the minus d over 10. And now we calculate the variance as the second moment, e of y squared, minus the square of the first moment, which is e of y squared. So it's 200 e to the minus d over 10 minus 10 times e to the minus d over 10, the whole quantity squared. That's equal to 100 times 2 e to the minus 0.1 d minus e to the minus 0.2 d, or 100 times e to the minus d over 10 minus e to the minus d over 5. 0.2 is 1/5. And that's answer D. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.